So let's talk about something that's always felt like straight up science fiction, but is now, well, actually happening. An AI that can literally rewrite its own code to upgrade itself. Here's the big question, the one that frames this whole explainer. What if an AI could just look at its own programming, see where it's falling short, and then just fix it? We're not talking about just learning from data here. We're talking about actively redesigning its own core functions. Okay, so to really get our heads around this, we need to talk about what's called an agent system. And the best way to think about it is with this analogy. Imagine a powerful AI model, like a big language model, is a brilliant, world-class chef. The agent system? That's the entire kitchen the chef works in. All the tools, the appliances, the workflow, the whole shebang. Now, traditionally, if you wanted to improve that kitchen, a human had to come in and do all the upgrades. But what if the chef could also be the one redesigning the kitchen? This is exactly where some new research is taking us, with a pretty radical approach, a truly self-upgrading AI. And that's where Sika comes in. It stands for Self-Improving Coding Agent. With Sika, the AI isn't just the chef cooking the meal. It's also the architect who can look at the blueprints of the kitchen, its own code, and say, you know what, I can make this better, and then actually do it. It's a huge leap forward. Now, this is a huge deal and a big departure from how things used to be done. See, before, you might have one AI, a meta agent, trying to improve a totally separate target agent. It's kind of like having a kitchen designer who has never cooked a meal in their life. Sika gets rid of that split. The agent doing the work is the exact same one making the improvements. And that's the magic, because it creates this incredible feedback loop for compounding gains. As it gets better at coding, it can make even smarter upgrades to itself next time. All right, so you're probably wondering, how on earth does it actually do this? The high-level method is really quite elegant. It's a simple but incredibly powerful self-improvement loop. So it's basically a cycle that just keeps going. Sika has this archive of all its past selves. First, it looks through the archive and picks out the best performing version of itself to date. Then it gives that version a simple instruction: make yourself better. The agent then literally edits its own code to create a new version of itself. This new agent is then tested on a bunch of hard problems to see how well it did. And finally, that new agent and its score get added back into the archive. Then the whole process starts over. It's basically evolution, but happening at the speed of code. So, the method sounds cool in theory, right? But does it actually work? Let's get to the results, because this is where things get really, really interesting. The researchers threw Sika at this really tough benchmark called SWE Bench. It's basically a collection of real-world software problems from places like GitHub. And the very first version, Agent Zero, before it had done any self-improvement, well, it only solved about 17% of the problems. A respectable start for sure, but definitely lots of room for improvement. So how did it get better? This is the amazing part. It didn't just tweak a few things. It literally invented brand new tools for itself. It created something called a smart edit tool, so it could stop wasting time rewriting entire files from scratch. It built itself a code summarizer to get the gist of what it was looking at. It even built sophisticated tools using abstract syntax trees. Think of them like a detailed map of the code structure, so it could navigate complex code bases way more accurately. It was literally inventing a better set of tools for its own kitchen. And here it is. The big payoff. After just 14 of those self-improvement loops, Sika's performance on that same really hard benchmark just exploded, from 17% all the way up to 53%. That is a threefold jump in its ability to solve real-world coding problems, and it did it all by itself. And get this, it wasn't just about getting more answers right. It also got smarter and more efficient about it. Turns out, a better kitchen helps the chef work faster. This table shows that the average time it took to solve a problem actually dropped from over 130 seconds down to about 117, even while it was successfully tackling much harder problems. Okay, so this all sounds incredible, and it is. But let's be real. It's not perfect. It's not some magic bullet for every single AI task out there. And the researchers are super clear about its current limits. See, when they gave it tasks that were all about pure reasoning, things like advanced math problems, the picture changes completely.
you can see the improvement was, well, pretty marginal. What the agent learned to do was just get better at passing the problem off to its most powerful part, but it didn't really improve the process of reasoning.
And that really gets to the core of it, right? The big takeaway here is that Sika is amazing at upgrading its kitchen. The tools, the workflow, the code that manages everything. But it doesn't seem to be able to upgrade the chef. That is, the fundamental reasoning ability of the AI model it's built on. At least, not yet. All right, so let's pull back for a second. What does all of this actually mean for the future of AI? What are the big implications here?
The researchers themselves put it best in their conclusion. They said, our results demonstrate that self-improvement, implemented via an agent system editing its own codebase, is indeed possible. And that's huge. They've given us the first real proof that this wild idea of self-improving AI isn't just theory anymore, it's a practical reality.
Of course, this is just the beginning. The paper is really upfront about the limitations, like something called path dependency, where if the AI makes a bad choice early on, it can get stuck down a bad path. But the ideas for future work are just as exciting. I mean, imagine a system that doesn't just edit its code, but also fine-tunes its own AI brain at the same time. Or an AI that gets so smart it starts inventing its own tests to challenge itself in ways we haven't even thought of. And that really leaves us with this huge, kind of mind-bending question. For as long as AI has existed, we humans have been the architects, we've been the builders. But if these systems can start designing and improving themselves, then our role has to change, right? What do we become? Are we the guides instead of the builders? Curators instead of coders? That's the big question that this work leaves us to think about.